Welcome back to another M&S tutoring video in number sense and algebra. In our last video we learned how to solve a simple word problem. Now we're going to be looking into a more complex word problem, but the main idea is still here as to formatting the right equations. So let's read the word problem. Stephen is building a garden this summer. He wants the length of his garden to be 3 times the width. He has a total of 72 meters of fencing. If Stephen were to use all of the fencing, what would the length, width, and area of his garden be? Well, right off the bat, we can already tell that this word problem is a bit more complex than our first one. But if we look into it even further, it might not be as hard as it looks. So let's go step by step. Let's first of all define the variable. So we'll say in this, W is equal to the width. As of right now, we're keeping our variable as the width because it is basically the only thing we know. Since Stephen gives us the length in terms of the width, which is 3 times the width, and we have the width as well, we can easily find the width using the perimeter. So let's begin to solve this. First of all, let's look at what's important in this equation. Well, compared to the other one, there's a lot of more important things in this equation. It says he wants the length of his garden to be 3 times the width. So we'll say the length is 3 times the width. That's very important in this part. And then he also says he has a total of 72 meters of fencing. And he says if he were to use all of the fencing, what would the length, width, and area of his garden be? So this is also important. He says he wants to use all of this fencing. So let's start to solve this problem. First of all, we need to come up with an equation. So right off the bat, we have something that is given in meters, which is the fencing, which is one of the only constants we have. So he says he has a total of 72 meters of fencing. This means that the perimeter of his garden, since he uses all the fencing, so let's say the perimeter is equal to 72 meters, right? So we have the perimeter. But we know that perimeter is also equal to 2 times L plus W. This is also what perimeter is equal to. But in this, we have 2 variables. So we cannot really use 72 is equal to 2. We cannot use 72 is equal to, because 72 is also the perimeter, we cannot use L plus W because we do not know the value of L yet. But if you remember, on top it says the length of his garden is 3 times the width. So we can say that L, the length of his garden, is equal to 3 times the width. Right? Now that we know that L is 3 times the width, we can say that the perimeter, which is 2 factored L plus W, we can say the perimeter is equal to 2. And since L is 3W, we can write 3W plus W. Because the length, which is 3W in this case, this is basically the length, right? Plus W times 2 basically, and that's the perimeter. Now we have the perimeter in terms of only one variable. We can sub in the perimeter for 72 and solve for the width. We can say that the perimeter, which is 72, we know that because 72 meters is the total amount of fencing Stephen has. So 72 is equal to 2 times 3W plus W, right? And when we begin to solve this, we get 72 is equal to 2 factored, so 3W plus W. So collecting simple polynomials, since both of them have the same variable of W, we can say 2 times 4W, and then simplified to be 72 is equal to 8W. And now that we have this, we can quite easily say that W is equal to 72 over 8 as we divide both sides by 8. So 72 divided by 8 is equal to 8W divided by 72. So 72 divided by 8 is of course 9. So we can say 9 is equal to W. Oh, I made a mistake here. Ops. So we can say that 8W divided by 8, since we have to divide both sides of the equation by 8, and we can say that 9 is equal to W. So If you didn't really get this as I talked to you, we can visualize this using a diagram. So here we have like a diagram over here. We can draw it like this. Of course, it's not to scale and it's not straight either because I'm a very bad drawer. And over here we have the width and over here we have the length, right? Now in this case it says the perimeter, so I'm going to write the perimeter inside perimeter is equal to 72 meters, right? And it says that L is equal to 3W, right? So instead of writing L here, instead of writing L over here, we can instead just write 3W, right? 3W. And since the perimeter is basically all the sides of the rectangle, in this case the rectangle, just added together, we can say that 3W plus 3W, since there's two lengths, so over here and over here, 3W plus 3W plus W plus W, the two widths of course, is equal to 72. And using this method as well, we can get the same answer of 8W, simplified, sorry, 8W is equal to 72, and a final answer of W is equal to 9, meaning the width of the garden is 9. So let's verify this. So if we sub in 9 back into the equation on top over here, the perimeter equation, to be more specific, this equation right here, if we get the perimeter, which is 72, is equal to 72, we know that the width is indeed correct. And we can move on further to solving for the length over here and the area of the garden. So let's scroll down over here and we'll sub it into the equation. So we can say that 72 is equal to 2 times 3 times 9. Gonna run out of space here. 2 times 3 times 9 plus 9. So using BEDMAS, we can solve. We can say that 2 times inner bracket first. So 27 plus 9. 27 plus 9 is 36. So 72 is equal to 2 times 36. And of course, 32 times 6 is equal to 72. And we have 72 is equal to 72, meaning our width is correct. Now, let's solve for the length. Solving for the length in this case is really simple. You remember how we said before that the length is 3 times the width? Well, all we have to do is just sub W into the length equation for 9, saying L is equal to 3 times 9. So 9, 18, 27. So the length is equal to 27. So right now, our rectangle looks like this. You have this garden over here. Sorry, I meant garden. So it's, of course, it's rectangular. I forgot to mention it in the word problem there, but the garden is, in fact, rectangular. And the length over here is 27. And the width we know is 9. Now, the last thing that we didn't solve for in the word problem was the area of the garden. Well, the area is simply just length times width. And now that we know what the length is and we know what the width is, we can quite easily say that the area is simply just 27 times 9. Hold on, let me just pull out my calculator here. And of course, our area will be in units squared, so we can say that 27 times 9. So area is equal to 27 times 9, and the area, as a matter of fact, is 243 centimeters squared, right? Sorry, centimeters squared is the flat surface area of his garden, right? So now that we have solved all of this, we know how to solve a complex word problem using the skills we have learned to format an equation and using the answer we got from our first equation and subbing into another equation to find the other answers as well. So in this case, what we did first was we formatted an equation for the width, right? And then based off the width equation, we found the length, as we knew the length was 3 times the width. And with both the length and width equation, we found the area. So the complex word problems aren't really that hard. You just have to find something that was unknown first, which in this case was the width, and then use that to find something else, and use that to finally solve the problem. So thanks for watching the video, guys. If you learned something new, please subscribe and drop a thumbs up.